Okay, so here's the first new video of 2014, and what we're going to do is we're going to take a look at, given a table, how do you determine if that table is linear or not? So I have a table of points, 3 x's and 3 y's, okay? And you'll remember that we discussed in class that there must be some constant rate or some constant change, okay? And we also refer to rate as the slope. And a constant means that it must be the same all the way across the table. Now, what we're looking for is in order to get from one value to the next, what are we adding or subtracting? So in order to get from 4 to 7, we're adding 3. In order to get from 7 to 10, we're adding 3. In order to get from 1 to 2, we're adding 1. And in order to get from 2 to 3, we're adding 1. So since that is constant across the whole table, this is a linear table. Now, not only is it linear, but I could also declare that the slope, which if you remember my formula for slope, is change in, that's delta y, over change in delta x. So you have to remember it's change in y over change in x. So it's the positive 3 over positive 1, which can just be written as positive 3. Now it's important that I look at the x's and the y's. For example, if I take another table, very similar to the last one, but this time I go 1, 3, 4, and I go 4, 7, 10. Now, my y's are going up plus 3, plus 3. My x's are going up plus 2, plus 1. So if I look very carefully, the slope between the first set of points is actually positive 3 over positive 2. Over the second set of points, it's actually positive 3 over positive 1, and that's an issue because those fractions are not equal to each other. So in that case, this table is not linear. Now sometimes we hide a linear table a little bit better. For example, let's say I go 1, 3, 4, and let's say we go 5, 15, 20. First glance, you might look at this table and go, oh, that's up 10, but then we go up 5, and you might think right away, oh, that's not linear. But let's look very carefully at the y's. Up 2, up 1. And let's investigate very closely our slopes. 10 over 2 and 5 over 1. Well, it doesn't take much for us to remember that 10 over 2 is actually reduced to 5 over 1. So since the reduced slopes are the same, this again is a linear table. You may look back at the table and just recognize that the 2 was skipped on the x-axis, and the corresponding y that would go with that 2 would be a 10. One last example. Let's suppose I take a table of 4 values here, 2, 3, and 4, 5, 7, let's go negative 7, actually, negative 19, and negative 33. So pause your video and try this problem. And then when you're done with the problem, unpause your video and take a look at how you did. So I'm going down by 12, I'm going down by 12, and now I'm going down by 14. But let me check those x's. I'm going up by 1, I'm going up by 1, I'm going up by 1. So I've got slopes that are not constant. This table is not linear. Hopefully that helps you with your homework.